All right, I'm Krzysztof Kotowicz. I'm a security researcher, mostly focused on HTML5 and UI redressing techniques. And today I'm going to talk about using HTML5 to actually attack websites or attack users of those websites. HTML5, as you probably know, introduces many new elements that allow developers to construct much more responsive, much more future-rich applications. But at the same time, attackers have the same possibilities. They can also use the new APIs like, I don't know, drag and drop API, file API, WebSockets, offline web applications, and all those new HTML5 elements to actually make an evil website, an evil web application to harm the users. And I'm going to describe some example techniques that the attacker can use to actually perform some malicious activities. Let's meet Bob. This is our victim. What do we know about Bob? Well, he's a CSO of any company that we are interested in hacking. Of course, as a CSO, he has access to some interesting stuff. He can have important files, personal files on his computer. He can have some cookies that we are interested in. He has access to intranet for his website. And I don't like him. I don't like Bob at all as an attacker. So I want to pawn him in multiple ways. And the focus of this talk is going to be some example attacks on Bob on the websites that he uses that will allow me as an attacker to succeed in getting access to the information that Bob has access to. So the first attack scenario using HTML5 and related technologies. Let's imagine that Bob has a hobby. He's a web security enthusiast. He likes hacking. He's not very professional in it. He's just trying to learn something about SQL injection or XSS and so on. And as a CSO, he has access to interesting files. And I want to get those files from his hard disk, from his computer. But of course, Bob is not that stupid to simply lure him into a website and ask him to download an exe file for him to run to pawn his computer. I'm going to use some HTML5 technique to actually try to convince Bob to handle me these files unknowingly. Let's use something called file jacking. File jacking is based on a really obscure HTML5 feature called directory upload. This feature is very obscure. It's actually only used in Google Docs application, though it has been enabled in the WebKit browsers for a few years. There's only a single website on the internet that uses that feature. Of course, there are a few other websites that simply demo the feature, but none other serious web application uses it. And this is what it says on a tin. It's a directory upload. So as soon as you have input type equals file element on your web page, and you just give it a directory attribute, clicking on that input will not present you with an interface to upload a file. It will present a standard browse for folder, Windows dialog or OS X dialog or whatever operating system you are using. And as soon as you choose a folder, the JavaScript on a page gets read access to all the files within the directory and all those subdirectories. So you're basically allowing the JavaScript on a page to upload the whole directory to a web server, or read the file list, or scan the files and extract some snippets from it. You get access to file names, file sizes. You can read each and individual file from a directory. So the business plan for pawning Bob would be, let's set up a tempting web page that the Bob would be interested in visiting. Let's insert the input type equals file directory element, but overlay that element, the button from that element, with a simple choose download location button. Let's just wait for Bob and lure him into clicking that button. And when he thinks that he's actually choosing a download folder for any file that me, the website, wants to download to his hard disk, he's going to choose his, for example, I don't know, desktop or downloads folder. But instead of me downloading that file for Bob, he's uploading the whole directory to me, to the attacker, and I get access to all the files from the folder he chose. Here's how this website could have looked like. There's a simple form for the Bob to fill in, just to make him unaware, just to make him do some thinking and clicks and make him not really aware of what is happening, to drive his mindset of the actual button that is over here. And as soon as he fill out this form, I'm saying that I will download you a personalized hacking tricks document. Just choose the download location. He presses it. His operating system displays choose folder dialog. He chooses the folder, and I get access to all those files. This is a screenshot of a command and control center for the applications. As you can see, there's some PDFs, XLS files, and so on and so on. One would imagine that nobody would fall for the trick. So I've actually tried it in real life. I've set up a web page with the exact content that you've seen before. And I alerted my blog viewers for trying out this new web page and to try to download some hacking techniques for them. Of course, it had very limited exposure because my viewers are very precise. It's not a big group, but they are almost all of them are web security enthusiasts. So they know about web security. And this experiment has been running for like 13 months. It's still running now. And in that period of time, I got the actual connections from over 200 IPs, and those connections actually pressed the choose download folder, and I got access to their files. And I've got tons of interest in files that even the web security crowd uploaded unknowingly to me. I got a lot of those. Of course, I've only downloaded some images and file names of other documents, so as not to disclose many private stuff from my viewers' hard disks. But, as I said, these guys were website based. So I also got access to some PHP shells, some exploit codes, and so on. But I thought that no one would unknowingly let me access their private data, some financial documents, for example. I was wrong. I got access to some password lists, some letter of authorization, some staff documents, some resume, pricing recommendations. There were also some financial documents that I got access to. But, okay, I know about their own documents, very private documents, but surely, as they are, for example, contractors for some companies and doing pen tests on them, they wouldn't knowingly give me access to their clients' data. Well, I was wrong again. I got access to, I don't know, some SQL injection results, some crawling tests, some important questions for web developers, whatever that means, some logs from SSL strip, some paros. This is an invoice. As you can see, there's a security unarmed guard, XLS. I don't know what's in that file, but the name seemed very interesting. So this trick, though it's very stupid in creating it, it's also very effective in actually getting the access to the files of users. It is trivial to set up. You can filter the files that from the directory that the user chose by extension size. Just run any JavaScript-based logic to try to filter out the files that you're actually interested in and download them automatically. Unfortunately, it is Chrome only. Chrome is or the WebKit browsers only. Only them allow the directory attribute of input type equals file element. And of course, it requires some user interaction, so the user must be prone to social engineering. And this was like an introductory way of pawning Bob. Let's see some other attack. Let's imagine that Bob travels a lot and uses Facebook. As he travels a lot, he uses multiple Wi-Fi access points in various airports, cafes, and so on and so on. But I want to control Bob's Facebook account. And I want to control it even when he changes the password. I don't want to, for example, control Bob's Facebook account only by him leaking me the current password for this one. I need it to be permanent. Also, I would really like to fingerprint Bob's intranet to see what applications is he using in the intranet. Maybe there are some old versions to try to fingerprint them and so on. Well, the solution is very simple. Just use some rogue access point. So construct a malicious Wi-Fi access point when you can modify the traffic. So you're actively performing man-in-the-middle attack on Bob. But also use app cache poisoning. What is app cache poisoning? Well, app cache poisoning comes from a specification of HTML5 called offline web applications. And it's a way of applications to define, to instruct the browsers what resources, what URLs should the browser download and store on disk permanently and not request those resources from the server. It is separate from the usual HTTP cache that is also used by browsers because there's no HTTP headers involved in the specification. How would you specify which resources are available to download and which resources should actually be downloaded by the supporting browser? Well, you put the manifest attribute in the HTML element of a page, and you specify a URL here. Of course, this has to be within the same domain. And this cache manifest is a simple text file listing the documents or resources that should be downloaded and stored permanently in a separate cache than the usual HTTP cache within the browser's profile. And the tricky thing is that unlike the usual HTTP cache, which has its own expiration rules, like for example, you can specify a maximum age of document. The HTTP offline web applications cache expires only when the manifest is changed. So when a browser, when the user visits the same resource, let's say this is a root of a website. If the user enters the same URL in his browser's address bar, presses enter, the browser sees that there's a manifest related with that website from the offline web cache. It tries to refetch the cache manifest from the server. And if it doesn't change, well, it simply uses the offline version, the version stored in the cache. But if the cache manifest cache manifest online is changed, all the URLs will get retrieved and the cache would get pruned. So we can abuse that fact to make a phased attack. First, we make Bob connect to our rogue access Wi-Fi point. We can actively monitor and tamper with the traffic that he's sending to, I don't know, Facebook, say. Then we inject a poison. I'm going to show what the poison looks like. After that, he disconnects from our Wi-Fi access point, so we no longer have access to his traffic. We can't monitor it. He goes to his company and, for example, visits Facebook again. Why not? And as soon as he visits Facebook, our poison is still running, and I am able to perform actions just like before. Phase 3 is obviously profit. So let me show you a demo of that in action. Okay, so this is Bob. He's visiting facebook.com. And now I'm trying to do the man-in-the-middle attack on Bob's computer. I will simulate it with using SSL strip and a proxy. So I'm not performing a real man-in-the-middle attack, how it would look like in the real life. I'm just using that on localhost on my computer. So I'm running SSL strip. I'm changing my proxy settings to use the SSL strip running on a port, and now I can actively modify the traffic. So as soon as he visits Facebook, I have added some visual effect that the traffic is actually monitored. But what is interesting is that here there's the manifest attribute appended to the HTML element, and it points to the robot's text file. We will see why in a moment. Okay, and of course I appended some malicious script. As an example, I can simply hijack the login form and alert his credentials. Okay, I can also visit Hacking Paris website, and in a moment you'll see what happens. Yeah, there's also a simple proof that I can monitor the traffic, and I did a console log evaluation and alerted this message to the log. Yeah, now I'm ending the man-in-the-middle attack. I'm no longer able to monitor and tamper with the traffic, so I'm changing the proxy proxy settings. And let's go to Facebook again. See, it is still the poison Facebook with the manifest still in place, and of course the script is still running. And Hacking Paris also has this poison active, and as a bonus, a separate website, Brucon, also has the poison running here. So actually, we can see here that the application cache for the Facebook domain is still running, and this is the cache manifest. This is the actual cache manifest. Let me just maybe move the. Yeah, this is the actual cache manifest that's the poison for Bob. And what I actually also did, I just modified the Google Analytics script, which is used all over the web. And this is an old trick that's just a bonus to the attack with app cache poison. So this was what was alerting in the console. Of course, the only mitigation for Bob is to clear his cache. But the important thing is this one. In English, it will be remove your cookies and other data from websites, I guess. So only when this checkbox is checked would the app cache get actually removed. Yeah, this will. So what actually did we abuse? Well, we abused two things. The first thing is the specification says that the manifest file has to be of a certain MIME type. And if it isn't, it won't get processed. And the second quirk that I used is that the WebKit browsers or Chrome browser it doesn't need the user intervention or interaction or confirmation to actually fill a cache. If a website asks to be cached by the offline web applications cache, Chrome will silently just allow it. Firefox, for example, will display a confirmation box. So what I did while man-in-the-middling Bob, I have appended the manifest pointing to a robots text file and appended the evil script. Also, I have tampered the robots text that was requested by the browser because of this entry. And this is a poison. This simply says cache the main page, cache this HTML document with the modified payload, and fetch from the network everything else. So the Facebook would work like usual. All those other style sheets, images, and so on would get fetched online and updated every time. But later on, when I'm no longer modifying the traffic, Bob visits the victim website. In this case, this was a Facebook. It is being fetched from app cache. The manifest file is being checked. So it sends the GET request for the robots text file. But, of course, robot text on a real Facebook server is just a text plain document. So the browser says, okay, there is no new manifest. This was just a wrong MIME type. Sorry, I'm going to use the old cache. So the tainted application cache is still being used. With this technique, we can basically poison any URL, of course, under the condition that it's not SSL encrypted. The payload stays until it is manually removed by the user. And by the way, if you are clearing the cache while browsing through a malicious access point, it's not enough, because I can actively monitor the traffic and inject it, for example, every second. With every second, I can repopulate the cache that you are just clearing. So if you want to clear the cache and stay safe, do it after disconnecting from the from the Wi-Fi access point that you suspect is doing some harm to you. Of course, it needs an active man in the middle to inject. You can try this technique with the fork that I made from SSL strip with added the tampering with the application cache. Okay, the third attack. Let's imagine that Bob really loves sharing photos on pretty much any photo sharing site, Instagram or Flickr or Facebook even. And let's imagine that I want to replace Bob as CSO. So I'm really interested in discrediting Bob. And one easy way to discredit someone is to upload either a concerning image on his behalf on the public website, and then, I don't know, draw the journalist's attention. So this is one simple way of discrediting people. And the question is, can HTML5 actually help in that? Of course, it can with a silent file upload. Silent file upload is the way of silently uploading file. So what I'm actually doing is I'm simulating what request would the browser send to the target application if Bob would simply choose any file from this element, choose a file from his hard disk and press the submit of the form. And with this technique, I can make Bob send pretty much any file name and any file content. What is important, I'm not trying to send a file from Bob's hard disk. I don't have access to those unless I'm file jacking. I'm trying to manually, silently construct a file upload request with the file contents of my control. So, for example, I can inject with JavaScript this little image without even touching Bob's hard drive. The silent file upload uses yet another HTML5 feature called cross-origin resource sharing. And cross-origin resource sharing, to put it shortly, is just a cross-domain AJAX, so a technique that is used for years to create responsive web applications. And what is the setup? Well, the setup is that I need to lure Bob into visiting my page. And within that page, very simply a JavaScript code constructing an XML HTTP request object and sending a post request to the victim. This is a photo sharing site, for example. Setting the content type, it doesn't have to be a text plain. We'll modify it in a moment. And using with credential flag. With credential flag is the new feature of HTML5 cross-origin resource sharing. It simply says attach cookies to the request. Attach cookies that the browser has for the victim website. And what is important, within the post body, I can send anything I want. This is this doesn't have the limits of the usual form submit method of submitting a form quietly. What I'm actually doing is I'm using the cross-origin resource sharing to construct a multi-part form data request. This is the most popular MIME type for handling file uploads in the internet. So I'm setting the content type of multi-part form data with a certain boundary, and I'm constructing manually the whole MIME request or MIME type of request. In here, there's the binary file data, but I simply passed as a parameter to this function. And of course, there's a boundary. This is the file name, and I'm sending this whole text, this whole body to the target web server. Of course, this requires a cross-site request forgery vulnerability in a website. So if a website accepts files or accepts forms in general without a certain token, unique token that is not known to the attacker, well, we can use that trick. What is also important, we don't get access to the actual response from the server. So we're simply sending a blind request with the file uploaded, and let's hope for the best that the file actually got submitted. So let me show you an actual demo of what happened. This is a demo from, I think, around a year and a half, when I found the CSRF flow in Flickr file upload. And this is just a demonstration of how it looks, how the attack looks like. First, I'm logging into to Flickr, to a photo sharing website by Yahoo. Flickr is a very fine application that, as you can see, I have no cookies here. This is empty account. Flickr is very nice because it uses the remember me cookie. So a permanent cookie that stays throughout browser sessions. So I can abuse the Flickr application having the CSRF flow without needing the user to be actually using Flickr on a separate tab, for example, without having him actively logged into Flickr within his browser session, because the remember me cookie handles the authentication of Flickr user for me. And Bob, let's say he visits my attacker website. He presses some button. Of course, this is optional to press a button. And as you can probably see here, sorry, I skipped. Yeah, he visits my website, presses see? Here I'm posting to the Flickr application photos upload transfer. This was a form that was not used in whole Flickr because Flickr went up to and I uploaded a file on behalf of a user. Flickr used Flash to handle uploads, but it also had a fallback mechanism with usual standard HTML file upload form. And of course, this particular form had a CSRF token. And in general, Flickr uses CSRF tokens for authenticating form submissions, but it simply didn't check the token on that particular form. So they knew something was happening. They knew that the CSRF is really dangerous, but that they had no clue on how to protect the file upload forms, because there are very unique ways of how one can forge a file upload form within the browser. There was some ways you could do it in Flash a few years ago. There was some browser bugs that allowed you to make an arbitrary post request with anybody, but it was like a few months period in 2006 or 7, I guess, when you could do that, and the bug was quickly fixed. So now you have a standard feature, which is a part of HTML5, that allows you to upload any file on a victim website, as long as this victim website doesn't use CSRF tokens. The same flow was recently found in the Glassfish Enterprise server. It was found by Roberto Suggi Liverani, and as it turns out, the Glassfish Enterprise server administrative interface doesn't have CSRF token for the admin user, and the admin user is very powerful because he can upload the WAR applications. So basically, with having a logged in admin user on a separate tab and exploiting the fact that there's no CSRF anti-CSRF tokens required by the file upload form, or the application upload form in this case, you get a remote code execution, because you can upload pretty much any Java application here, and it would run in the context of the server. This was a pretty big bug. Of course, it's fixed now by the Oracle. Let's now get back to basics. Who of you know what is the same origin policy? One person, okay. So let's get to basics really quick. Well, cross-origin policy is what makes the current web relatively safe. Basically, it's a restriction of communications between websites of different origins or different domains, DNS domains, let's say. Basically, the most common form of same origin policy says that the website A cannot read the resources of website B, like cannot read its HTML content, cannot read the script, and so on and so on. Of course, the same origin policy can be relaxed, and there are several mechanisms for that. Cross-origin resource sharing is a mechanism that allows you to relax the same origin policy. But at the same time, same origin policy can be ignored. You can simply use your users to bypass the same origin policy for you. So by requiring user interaction, you can abuse the users to perform actions that are forbidden because of same origin policy. But UI redressing is a really hard term, and I don't like it at all. What I like to call those techniques is Jedi mind tricks, because that's what you are actually doing. You are playing Jedi mind tricks on the victim users. You are trying to convince them that they are not looking at the page that they are actually looking at, that they are not clicking the thing that they are clicking, they are not dragging, typing, copying, and all those actions that the users usually perform when interacting with applications can be simulated, emulated, or obfuscated. And as a result, victims attack the applications for us. The most common form of UI redressing attacks is a clickjacking, but unfortunately we don't have time to describe what clickjacking is. So let's see another technique of UI redressing. Let's imagine that Bob likes online games, and I found through the reconnaissance of his intranet that he is using a vulnerable website somewhere in his intranet. But the website is vulnerable to XSS in a very specific way that makes the to be able to launch, for example, the XSS, the Bob has to type the payload itself in the input field of the application. So very tricky to make someone type in the XSS payload unknowingly. So let's make Bob play a game. Yeah, this is the example of such an application. Of course, it has a, as you can see, XSS flow here in this field. But the point is, there's no URL that I could hand the user to just simply press enter on this field or click a link with a URL that would trigger the exploit. So I need to come up on something different. Come up with something different. See, yeah, I've set up a game on a separate origin, separate domain. This is attacker. Yeah, and the game looks like this. He drags some letters, and now he's asked to check the score of the game. And as soon as he presses the check score, I'm simply executing the payload in the context of victim application. What actually happened is that the first few letters are just to confuse the user, to make him do drag and drop very quickly. And the last one, the letter G, is when the iframe appears here. Of course, it is invisible usually, and it travels with a mouse. This is also a very popular form of or technique of URL redressing attacks. And as soon as he drops the letter G here, he's actually dropping the payload that is embedded within the letter G using the drag and drop API on the input field on the victim application. And of course, I only need to make him click the search button here to trigger the exploit, which is obfuscated with this check score. So this is a technique called drag into. You can trigger self-XSS. You can pretty much fill out any form of a victim application with your hidden content, attacker's content. Unfortunately, it's Firefox only, and it will die. The bug will die soon. I would say about 3 months, because someone is already fixing the bug in a Firefox code. Of course, there's the next frame options, which is the best currently known defense from URL redressing attacks, and as soon as website uses that header, this wouldn't get executed. And the last one I would like to show you is let's imagine that Bob has access to an internal HR applications with all the salaries of his subordinates and his own and so on. But I really want to know his salary because I want to replace Bob, and I need to know what kind of benefits would I get from the company. So let's make Bob play a game again. The technique is I'm using the 2 images. One is overlaid with an iframe of a victim application, and the other is overlaid with a text area. These both are invisible. And I'm trying, this is the HTML code, I'm trying to make him drag something out of the victim application to the text area. And as soon as he drops something, I get access to the actual content that he was dragging here from the victim application. Let's see a demo, and it will be the last demo. Yeah. So this is a game of dragging and dropping, dragging the balls to the basket. You might see something fishy in a moment, but yeah. You see, I get access to the actual HTML source of the victim application. What actually happened? What actually happened is that, yeah, let me just show the source, right? So the first balls are the usual trick, nothing really fishy, just make him drag and drop. There's an iframe, invisible, and he's dragging the ball to the basket. So the first step is he's just selecting the HTML source, cleverly positioned on the line that I want to get access to. And now he's dragging that on my text area, and I get access to the HTML. Of course, this technique is also Firefox only because it relies on cross-origin drag and dropping. and no other browser allows me to do the drag and drop actions cross-origin. So, a brief summary. HTML5 is a really nifty tool, not only for the web developers, but for the attackers also. And attackers can create applications which are malicious too, and they can abuse the legitimate APIs that HTML5 allowed. Also, it is a very bad idea for a web application to allow to be framed. So I would really recommend to use the X-frame options deny in the web application that you probably develop. And also you can abuse the users and make them extract the content, for example, for you, or inject the payloads for you. Thank you. This is some websites that you probably want to visit if you're interested in a subject, my Twitter and so on. Do you have any questions about the subject? Yeah?
About your second cache technique, second payload. You said that you choose only in Chrome, and you have to be defended from this kind of thing. You have to delete your cookies, etc. What happens when you